Hello everyone, this is Eren Şahin. I'm a sales engineer from liNear. Today's topic is heat load calculation with linear solutions on Revit. I will use modules building analyze to detect the building heating to apply heat loss calculation, and desktop heating for panel heating and radiator layout in this webinar. There are many different standards to calculate the heat load of a building. Although they are similar to each other, necessary parameters vary across the world. In order to determine the heat load of a building in accordance with standards, architectural model of the building, starting with the building materials, the room components, the geometric division into stories and rooms, as well as temperatures, must be detected in a structured manner. liNear transfers this building data directly from the CAD model with the help of building detection commands. We will use the building analyze module to detect the building. It offers functions to prepare the MEP 3D model on the base of architectural model, to analyze it, and then to create a calculation model as a basis for heat loss and cooling load calculations. You can easily do zoning and view management from the linear control board. It enables the bidirectional exchange between these calculations and the CAD model. All building sections, stories, rooms, and architectural components are transferred, including room temperatures and U values, to linear building. It recognizes sandwich wall and floor construction from linked files and detects them as one wall. In addition to the transfer of building information into calculation, the calculation results can also be transferred into the model later on. Also, you can manage all parameters with linear parameter manager. linear building provides many tools such as tables, standard references, copy functions, quick dimensioning, and so on, in order to make heat loss calculation as simple as possible. It directs you to input all necessary parameters for the standard that you selected. For U values, if they have not yet been preset in the Revit model, you can use linear master tables and select building materials from standard tables such as European norms and ASHRAE. When you complete your calculations, you can dimension radiators or panel heating circuits based on calculation results. For the dimensioning, you can use extensive linear product library. With this way, you can apply your calculations and create your model with real manufacturer products, and the material list will be 100% accurate. linear desktop modules makes Revit a real MEP tool. Beyond all construction tools, it will sort, bundle, and simplify all required functions based on the workflow. From the combination of currently selected building part, story, discipline, and the view type, linear desktop will create views with all the settings that enable you to see exactly what you intended to see, moreover, how you want to have it displayed. With piping, routing, connection, and parallel pipes command, you can save time and increase your productivity. With pipe offset command and linear collision detection, you can create your model with the best quality and accuracy. Now we will see how to work on Revit. If you do the planning on Revit and U values are already inserted into architectural components, for example by the architect, you won't spend time by adding these values into the components. All you have to do is detecting the building with zoning and adding missing parameters. First, we start to detect a Revit project with linear building analyze. We open a Revit project with linear template. Here we will click on Links command in the Construction tab for the architecture discipline. We add our architectural model as a link file. Then we click on OK. As you see, it is imported. And then we will import floors from architecture to our project. In order to do this, we click on Stories command and then select Import Synchronize command. Here we select all building stories and say OK. It asks if it should remove existing floors, and we say yes, and it creates all floors. But first we have to create a view for each floor. For that, in Project tab, liNear asks us 3 questions. First of it, where? So we select where do we want this view. In this case, we select the floor and the building part, and then we pass on second step. Second step is what? So we select what discipline do we want to work on. And the third is how. So we choose what type of view do we want to create. We select floor plan and click on this plus sign. Here we select all floors that we want to create a view. If we want to work on more than one discipline for these views, we can select this discipline from here. When we create views, as you see, views for each floors have been created. In next step, we will create MEP spaces. For this, we move to the Construction tab again. As you see, we have a command named Create Spaces. In details of this command, liNear has some options like if it will be made automatically or manually, filling shafts, and tag on placement. For this case, we leave these options checked and create spaces automatically. Also, the user can always be sure that these spaces are placed correctly and occupy the correct volume even in the rooms with inclined walls. And in the rooftop, we don't have any rooms, so we close this tab. There are also some other options for data transfer. We can select room's name and number and also add further parameters for these spaces. Before we continue, I would like to show you our parameter manager. liNear parameter manager allows you to assign calculated or written liNear parameters to your own shared parameters in a mapping table. As you can see in here, there are a lot of liNear parameters with their explanations. You can easily select the discipline that you work on and filter these rows. When we select Building Analyze, as you can see, there are some liNear parameters and some parameters that are taken from the architecture. Whichever you place the first will be activated in the project, and this data will be written into the component. In this case, components are spaces. When you place the parameter that taken from the architecture and check liNear properties, you can see in here, you will see it is taken and cannot be changed. If you prioritize a liNear parameter, here we select the Building Analyze again and put this liNear parameters first, and we click on OK. As you can see, it can be changed to another value. You always have the option to choose between liNear datas or the datas that comes with any kind of components. After we finish our calculations, we will transfer datas from liNear building to Revit, and it will be seen at the Revit properties, and you will be able to map these parameters in the liNear parameter manager too. In this step, we will do zoning. With this operation, we will determine heating and cooling temperatures for rooms. When we click on Zoning command with Zones option, we see all rooms are listed. If we select Levels option, we can see rooms categorized by their levels. Zones option is easier to use because with this way we can put similar rooms in different floors into the same zone. Then we start zoning. we can mark multiple rooms with Control button or the Shift button. And when we right click to choose the zone selected for the rooms, these target temperatures will be added into the room data. Also, you can search for the rooms with the same name. For example, when we search for office, it will show us all office rooms. If you want to add another zone category, you should open liNear options, and in the Building Analyze tab, you can add new categories for new zones. Now we've finished zoning, and then we pass to the Analyze tab and click on Building Detection. Click on Transfer Building from CAD and select the International template. The whole building data is being analyzed. The thermal properties of the components, temperatures of spaces and zones, outside and inside walls with correct reference, and much more. And liNear building is opened. As you can see here, geometrical values are taken automatically. Now we start to apply heat loss calculation. First we open the heat load tab from the menu. In here we can see our project with floors and rooms in a tree view. At the right hand side we can see commands for entering additional parameters based on standards. In case the model was accurately created and prepared in advance, the preliminary heat load is already calculated. Before we go on, I will show you some other ways of model-based heat load calculation. For example, if you work with open BIM workflows and have the architectural model in IFC format, you can easily go to Links and select IFC. When you add your IFC model from here and click on OK, liNear will still detect the building, and you can create your zones and rooms, and you can save all necessary information into the model, and you can easily transfer this data to liNear building, just like the same way that we did with the Revit model. For example, you are currently on the very early planning stage and you don't have a Revit or IFC model, and all you have is a 2D floor plan. In that case, you need to create an architectural model from this 2D plan, even if you're not an architect. But you know what? No problem if you have liNear. You can just go to Links and select CAD formats. And in here, you can add the DWG file and insert it. Here, we have our floor plan. And in Construction tab, we have this Walls command. Here, we can activate this command and select the thickness of the wall. And then when you activate the main command and construct this external walls, as you see, you can do this very easily. You just have to select the midpoints and continue to draw around the floor. Select here, continue, select the middle point. As you see, all external walls are created. And for internal walls, we escape this command and uncheck this box and select the thickness, and then activate this walls command and start drawing the internal walls. We do the same thing like we did with the external walls. Activate this again. Now this the other side. We're almost done. Yep, we finished drawing our internal walls too. Now we will create our windows, and for this we open our Windows command. From here we select the height and the parapet height, and then we will activate the command and check both sides of windows. To see all windows, we change our view to wireframe and activate this command. And when we select two sides, it will create the window. It's very easy. You can do it very fast. You just have to write down its heights and you give its width with selecting its two sides. And now we will continue with the doors, but we forgot to draw this part of this internal walls. So select the thickness again. Yes, we completed this part. Now we will draw our doors. Doors command is almost the same with the windows, but you also select the opening direction. You give the height and the door sill height, and then you activate the command. You select two sides of the door and the opening direction, and it will create the door. It's very simple. And if you want a double door, you can check this box and create the double door, just like we did this one. Now we will create our floors. In order to do this, we activate the floors command and we select all walls, and when we finish, now let's create a 3D view. Now you see the floor is created. To create the ceiling, we open stories and then we create a new story in the upper level of our ground floor, and when we click on OK, now we create a view in upper floor, and then we create these floors. We select all walls and then we apply the command, say yes. As you see, the ceiling is created. After we finish our construction, we can go to the ground floor and create spaces, and as you see, all rooms are created for this project. And with this project you can do zoning and you can transfer this model to linear building and calculate the heat load or cooling load from this interface. And as you see, we can easily create the architectural model from 2D plan even if we're not an architect. And now we go back to the linear building to complete our heat loss calculation. And let's check these parameters in more detail. First, we need to select which standard we will use for our heat loss calculation. When you click on here, the basis of calculation, you can see there are a lot of standards and you can select either one of them. When you do your selection, as you see, these parameters will change based on needed data for the method. We will use the European norm EN 12831 for this calculation. With this command, we select our location. As we selected the international template, there are some countries and cities, as you can see in here. When we select one of them, it will take the temperature value and if it's a windy region or not. Of course, we can change these values right here. And if you want to add another city, we can simply do this from the program files. Here we can also select the building mass, and for this we have options such as light, medium or heavy construction. And in here, we will select the shielding class. We can select between no shielding, good or moderate shielding. And in here, we will select the air change rate. We can type this value or click on this calculator and select the category that defines our building. And lastly, we can enter values if there is a mechanical ventilation in our building and if there is any additional capacity from here. We also have one more tab in here, and this is for intermittent heating operation. We select if there is an additional heat up capacity globally, room-wise, or at the building unit level, and then we select other parameters based on this. As I said earlier, every parameter we determined in here are according to the selected standard. Now we will check out the U values. In order to do this, we move to the master tables. Here we have all building materials with their thermal properties. And in here, there are internal, external walls, windows, and doors that are already prepared. Or we can easily create our walls, floors, ceilings, and doors when we click on this new command. Also, we can create windows. When we create our windows, we give values for these properties. After we create this configuration, we can save it to the master tables. Because we work with already prepared Revit model, our building components are already configured. As you see right here, these components are taken with their specified values, and their building material number starts with REV initials, and this means that they are taken from Revit. But if we want to change something, we can easily click this command and change its U value, or we can add new material and create another wall in here. Also, from here, we can see the temperature profile of a configured wall. If we want to change the U value for a wall type in our model, for example, we want to change all walls with this configuration to a new type of configuration that we created. From here, we can go to the exchange U value command right here and select the code of the wall and change it with the available U values right here. The wall that we created from the master table will be listed right here. We can also select a wall that is already in liNear database and change it with that one too. And when we go back to our tree view and select a room, here we can see all architectural components in the room. As you see, there's a floor, ceiling, external wall, and internal walls, and there are windows and doors subtracted from this external and internal walls. And we can see their dimensions, adjoining areas, and heat losses of that particular components. And when we click on the support button, in results, we can see the total heat losses from transmission and ventilation, and also heat loads per meter square and meter cube. Now we will dimension heating systems and transfer them into our Revit model. We go to the model overview and we select the radiator. And this is the interface for pre-selection. Here we can select a manufacturer, or we can just use a neutral component. And with this command, we can select boundary conditions for dimensioning. Here we will determine the design target, the heating capacity is fixed and differential temperature is determined, or differential temperature is fixed and heating capacity is determined. And based on this design target, we select the supply water and return water temperature, the minimum differential temperature and maximum, and also we select minimum mass flow rate per radiator and maximum mass flow rate per radiator. Also, we can select either we want one pipe or two pipe system for our heating system. And from right here, we select the connecting set for our radiator. We will do the dimensioning for the ground level. If we uncheck one of the rooms in here, the dimensioning will not be applied for that room. And we deselect the apartment right and living room because we will implement the panel heating system for this room. We will uncheck stairs. For the other rooms, we just click on the 3-dimension command, and as you see, it automatically dimensioned radiators for rooms based on the boundary conditions that is selected and with the reference of windows. For example, if you select the sleeping room right here, it has the heat load of 986 watts, and these 2 radiators under 2 windows are fulfilling the design target. And now we will transfer this into the Revit model. First we will connect the CAD with the linear building, and then when we click on this draw command, as you see, their colors turn to blue, and this means that they are implemented into the CAD. And when we check out, as you see that all radiators are placed under windows. And when you check out their properties, you see their design, heat capacities, and mass flow rates are right here. Let's continue with the panel heating circuit. We went back to the linear building and we select panel heating. Here we go to the project and select a manufacturer first. As you see, there are different presettings for panel systems. In system parameters, we can select the minimum and maximum pipe spacing, and this depends on the manufacturer data. We can also set minimum circuit length, maximum pressure loss, and so on. The selection of the coil partitioning will affect the material list. Also in here we can select the grid additive, and it will also be in the material list. We will determine the supply water temperature and return water temperature from here, because we select the differential temperature minimum and maximum values, and in here we select is it only for heating or in mixed mode. And from here we can limit surface temperatures. This is also a boundary condition. If surface temperature exceeds this limit, program will notify us to correct this issue. And now let's dimension our panel heating circuits and transfer them to CAD just like we did with the radiators. Now we go back to the CAD and we find the room. This is the living apartment right, 04. First, we need to create a pipe laying area. We select the discipline for panel heating and cooling and the ground floor, and we create this view. In this view, in the construction tab of the panel heating and cooling, we go to the area plan, and then we create an area in a room. Select the room and click escape. And now the pipe laying area has been created. Let's go back to linear building and go to our room. This is the room that we are going to implement our panel heating system. We click here and click on the occupied zones. As you see, 3 circuits are inserted in this room, and their total heating capacity is 1494 watts, and it supplies the heat load of the room. And when we go here, we can see the areas of this circuit, and we also see the laying spaces, the differential temperatures, the pressure losses, pipe lengths, mass flow rates, and so on. And now we will transfer this panel circuits into our CAD file. In order to do this, we use the same command that we used in radiators. We click on draw, and then we select our pipe laying area, and then it asks us to select the start site, and we select here. As you see, these three circuits are implemented. And now their colors also turn to blue. We go back to the CAD and we can see these circuits are implemented. And if we want to change the laying pattern or the pipe spacing, we can just change this and assign settings to the selected circuit, and as you see, it is changed. And now when we go back to linear building and select apply drawn pipe lengths and search new components in CAD, and we start it, as you see in here, its orientation, its pattern is changed to meander, and these ones are spiral, and also the laying spaces, and this circuit's laying space is 100 millimeter right now. And if we change one in here, and for example, let's select 50 millimeters, and it asks us, should circuits of the same type have the same laying spaces? We say no, because we only want to change this one. And then we refresh again. We say transfer results to CAD and apply calculated pipe lengths. We start this. As you see, the pipe spaces of this circuit is changed to 50 millimeters. And I will show you one more thing in here. If you have many panel heating circuits in your project and it seems so complex, you can just select your circuits and you can check the simplify display command and assign the settings. And you say yes. As you see, this will represent the panel heating circuit right here. And this will improve the performance on large projects. We finished our calculations and dimensioning, and now we will have a report based on our results. We go back to linear building, and then we click on this little printer sign in here. And here, as you see, there are titles to create this report. We select the heat balance, completion of heat load calculation and detailed room-wise printout. We select radiators and panel heating, and these are, as you see, these are basically the same thing, but one of them in detail, the other one is more compact. And for the material list, we select long text without prices and short text without prices. We can also select the print language in different languages. As you see, we all worked on the English interface and we can have the printout in different language. And we click OK. Now we have our report. Here we can see all rooms and levels and their heat losses. And we go on, we can see the standard heat load according to our standard, and we can see all parameters that we selected right here. And when we continue, we see room-wise printout, the heat loss calculation, and you can see all details in the room, all architectural components with their properties and their heat losses. And then we go on and we can, and here we can see the radiators completion, and you can see all radiators in their rooms. We see one radiator in office, it's all calculation results and properties, and we see two radiators in a sleeping room. And when we continue, you can see the panel heating circuit on this room. This is the apartment right 04 living room, and we see these three circuits with its properties. And when we continue, this is also another title. This is based on manifolds, and this shows us the panel heating circuit. And we can also see more detailed page for panel heating circuit and the balance sheet for it. Then we continue, we see the material list. It shows us the total pipe in rolls. As you see, this is based on the manufacturer, and you see all room accessories and system accessories, discrete additive that is selected, and how many kilograms do we need. And when we continue, you can see more detailed explanation with its article number, and this is the detailed with long text, and the other one was with the short text. We have all the material list here. And now we have come to the end of this webinar. Today we applied heat loss calculation on a 3D Revit model. I used linear desktop building, building heating, and building analyze modules in this webinar. If you have any opinions on our webinar, or if you have any suggestions for topics that we should cover in our next webinars, please let us know. If you need more information about this subject or linear, you can reach us via export@linear.eu. If you want to watch this or previous webinars again, you can follow linear YouTube page. Thank you very much for your participation.